How about now?
Hey, Robert.
Looks like there's a countdown, so it's counting down.
Oh, that's nice. That's handy.
Is everybody muted as they get admitted?
They are. They have
Yeah.
to unmute themselves.
Ah, okay.
So on YouTube, there's still no video, but a countdown?
No, it's now shows the California Smalltalkers.
Oh, okay.
The slide. Michael's showing off his cup.
Cool.
Oh, that's interesting.
Okay, think you can hear me now?
Yes.
We can.
I was saying it's the best way to do Java. Oh, good. I was wondering why it didn't get a laugh after all that work.
Yay. I like a good punchline.
Sound check, anyone?
Yes.
I was saying it's the best way to do Java. Whoa, that's weird. Okay.
Someone needs to mute.
Oh, yeah. Mute your YouTube. Yay.
Ah,
So if you have
This is how we will
YouTube
spend the
running,
first
Or
10
just
minutes.
mute yourself entirely. Yeah.
turn off the sound in YouTube because that's delayed by, we don't know, 20 seconds at least.
whoa, that's weird.
Someone needs to mute.
Oh, yeah. Mute your YouTube.
Oh, and the feedback with the 10 seconds delay is great.
Or just mute yourself entirely.
Turn off the sound in YouTube because that's delayed by, we don't know, 20 seconds.
Now everyone but Dan and myself are muted. Dan, is your microphone the one that has your live image on it?
Yes.
Okay.
Good. Oh, I don't see myself anymore. Too many people on? Oh, there. I see. Okay, so we are going to wait for a little longer to give people time to join.
Yeah, there are 31 people so far. 73 people RSVP'd.
Mm-hmm.
And I guess newcomers cannot see what happened in the 8x8 text chat before they got here.
Mm-hmm. Oh, Mark says they can.
Hi, Dan. So excited to see you.
Hello there.
You're like the original founder of Smalltalk, right? One of them.
Could be. I don't know. There's a bunch of people.
What do you mean you don't know?
Yeah, between Alan and me, somewhere there. Oh yeah, I got the text chat finally going.
Well, the first programming language I ever used was Smalltalk, so
All right.
they made a huge influence on me. And I'd like that same influence to be available to everyone.
Good man.
Yes, I'm a kid. And yes, I'm going to work on the Dynabook vision.
All right, David.
Unfortunately, I can't download Frank.
We ought to do something about that.
Yes. Hey, Dan. Just thought I'd say hello in voice before we all got going as we're waiting.
Oh yeah, and I can't see who that is.
Oh, it's Mark Lenzner.
Oh, Mark. Hey.
Hey.
Good to see hear from you.
Yeah. Yes.
We were just talking a bit earlier. Craig and I. Craig had done some cool stuff, sort of allowing a mashup between Twitter being a source of input for programming, and then we were chatting about wheat, and
Oh yeah.
probably be interesting to a lot of people here to hear about wheat.
That crazy experience.
Yeah.
Yeah.
Yes. Also, Twitter as a programming source, there's in the Super Collider community, which I don't know if you know, Super Collider is a music system, and the language is sort of directly inspired from Smalltalk. I mean, the language is almost exactly textual Smalltalk. The Super Collider community has a Twitter stream where people post complete compositions in 130 characters or less.
Awesome.
And is there any depth behind it? In other words, can you put fragments of a composition into one message and then issue another that invokes them?
No, not that I know of, but
the thing I was playing with is stateful, so you can accumulate things.
I wonder whether a gzip. I wonder how small a gzipped spoon image running Space War would be.
No. Yeah, well, that was so. Craig, that was I don't know if I worked on this crazy language called Wheat for a couple of years. Yeah. And so, of course, having pointers be URLs was a sort of, or URLs are actual followable pointers was kind of a thing in that language. So
Yeah.
Right.
If I had a code golf in a tweet, I'd go with APL.
Gzip.
Well, at least now that they're Unicode.
I just found the URL for your week.
Space War in a tweet. I wonder whether anyone made
Some amazing things have happened. Amazing things have happened in the APL community. I want to take some time and get caught up.
I mean, for sure, you could make a language that has anything you want built in.
So we're 41 people now of the 73 who responded. So I guess we'll wait a little bit more, but no longer than 15 past.
Right.
Yeah, a little bit less than that might be reason. I mean, if we were frantically running around trying to get this person or that connected, then I would say keep waiting longer. But but if it's fairly sane here, we could probably go at 6:10. And you've got various things to say too.
Sure.
Wait a sec. That's macOS right there. Didn't Apple, they wanted to do on Spark, Alan and you just took all the stuff then, and then this Apple just left and then took it and made their own thing and made it blow up in their faces.
Holy hell.
Is that just Squeak.js or is there some other stuff too? So it looks to me
Dan,
like
how's the weather?
Weather's good. It's too good, really. I like weather. Storms and stuff.
Well, I was thinking about your old Squeak project, the weather station.
Oh yeah, yep. It's too good here for that to be interesting. It just does the same thing every day.
So I just did a very kludgy reflowing of the text of my slide around my video conferencing video thumbnail.
Mm-hmm.
Very good.
Thanks to Smalltalk. So yeah, with that, let's get started. Welcome everyone to California Smalltalkers. This is our first gathering. All the event information is at our meetup site, and please join. It's at meetup.com/California-Smalltalkers. All of these gatherings are simulcast and recorded on YouTube Live. So within a few days, we're going to put an edited version of this meeting there. And at each gathering, we're planning on having some announcements, then some lightning talks, a presentation, and then open discussion. And the whole thing nominally is about 2 hours. And let us know if you'd like to show something. You can get in touch with us and get all the other details about the group at our meetup page. So my name is Craig Latta, and with Vanessa Freudenberg and Dan Ingalls, we started this group. I first encountered Smalltalk in the music department at the University of California at Berkeley, and I've been using it for research into live-coded music and virtual reality since then. And I met Dan and Vanessa through the Squeak community. And recently I've been having fun teaching Smalltalk to newcomers on the web platform with Squeak.js. Now I'm going to hand it off to another of our co-organizers, Vanessa.
Hey, welcome everyone. I'm Vanessa Freudenberg. I chose that name last year. And I've been a member of the Squeak community forever. Right since 96, 97, I went on the Squeak mailing list. And later I actually worked with Dan in Alan's group. And lately I've been working on Squeak.js, which is a virtual machine implemented in JavaScript that is fully compatible with like most Squeak images, especially older images that don't require the fastest machines, but it can actually run even the latest Squeak version. So the third in our happy bunch and the first speaker for our first meeting today is Dan. Dan, who invented that language we all have with his group back in the 70s. And yeah, over to Dan.
You're muted, Dan.
There we go. Can you hear me? So I'm going to start off just chatting somewhat about me and where I came from and sort of how I came to Smalltalk. And about me having invented it, the truth is I did not invent it. Really, Alan invented it, but I got totally into it. And he's always said that he was the inventor and I was the architect, and that works for me. But I just thought I'd talk a bit about my history. As I say, a bunch of you know me, but some of you don't. And so that gives us some common ground. And also, when we were talking about doing this group, I wanted, I was just feeling, and especially with the COVID nonsense, kind of lonely and needing that kind of camaraderie that one gets from going to the pub and chatting with people or hanging out with geeks and chatting with them. And so that's how we came about doing this. And I think we want to, it'll take some time to see how we all want this to be, but I'm hoping it's a chance to maybe have a few lightning talks and then maybe one serious talk each time we get together, and enough time to just chat then about what came up in those various talks at the end. So, and I guess we'll just sort of find out what everybody has a stomach for in terms of length of time. But I'm hoping that everybody will send various suggestions that they may have about what they'd like to see, what they might like to present, and how they'd like to spend the time.
One thing, can everyone else turn off their videos, please, to save some bandwidth, and maybe then we'll come in a little bit more clear.
Yeah. So let's do this. Mm-hmm. Yeah, so this is, I won't talk about the first, the first one, but as around the age of, well, I guess sort of from 8 on up, I got interested in, tinkering with things, and especially electricity. And I walked to school. I was lucky to be able to do that. And around the age of 12, I became aware that everybody had their trash cans out on Thursdays. And so I started getting interested in what people were throwing away, because, one of the, I was going to say this at the beginning, the sort of, the fruitful soil for invention is lots of stuff and lots of time, and then ways to connect stuff together. That's part of it. And of course, the nourishment is then doing fun things with the stuff. So anyway, I did this, and word fairly soon came back to my parents that their son was dumpster diving, and that was a no-no. So we had a conversation, and they said, what you could do is write up a little sort of business card and take it around to everybody in the neighborhood that says, you're interested in stuff, you fix stuff, but even if you don't fix it, you'd love to play with it if it's, sort of electrical or mechanical, that kind of thing. I wasn't into getting old chairs and couches. So I did that, and it was a bonanza. I had so much stuff to play with, and so I, by this time, I finally had gotten over my fear of the furnace in the basement. So I started to build a little laboratory in the basement. And my father was a Sanskrit professor, and he never went in the basement, so that worked out fine in terms of our sharing of the space. And I just thought I'd mention like a couple of things I remember doing that were fun and sort of educational. I've somehow or other, I figured out what carbon arcs were. I think it came from shorting the carbon parts of batteries, something like that. And then I found out more about carbon arcs. And carbon arcs are a way to make an really intense light. And and I learned eventually, well, I blew a lot of fuses sort of doing this because I just tried plugging them in. And then I got a hold of a huge light bulb at a surplus place. It was a 1,500 watt light bulb. So I could put that in series with everything that I was doing. And it kept me from blowing fuses in the house. So that was good. And then I found out that you need an inductor to make a stable carbon arc. And I had around an old washing machine motor that was taken apart, and I just took up the coils from it, and it did just what I needed. So I had a really bright light that I could play with. And you know, one day, I mean, kids just try everything. I remember I was at a talk that somebody was giving about kids, and we were around a bunch of picnic tables, and he said, I bet you know what this picnic table tastes like. And I thought, oh my God, I do, you know, because you taste everything when you're a kid. So anyway, I thought, oh gee, this light is so bright, I wonder if I put a lens, if I could burn a hole in the wall. And it did a little bit, didn't do that well. It wasn't a huge amount of power. But in the process, I misplaced the lens a couple of times and wound up projecting what was going on in the carbon arc on the wall. And this was a real revelation to me. And that turned into looking at the surface of the sun projected and a whole sort of little science fair project about that. But that's just about exploration and invention that I thought I'd say something about. And I guess I'm trying to, I think probably most of the people on this call have had times like that and things like that they'd like to share. Down below that in the lower left is I got a huge magnet. It's the surplus place. By this time I was going to a surplus place out behind MIT, a good place for a surplus place, because I lived in Cambridge. And this was a magnet off of a magnetron. A magnetron is the thing that makes microwaves in your microwave oven, and it is the coolest design for a radio tube. I encourage you to read about them. But anyway, so one of the things I did was to move the carbon arc into the magnet, and it started behaving really weird. And part of that was because I was using alternating current, and things were just flying around. But also in the process of this, it just was making weird sounds too. And it occurred to me, oh gosh, I wonder if you could do something reasonable with sound in this magnet. So the carbon arc was much too energetic. So I wound up putting a candle in there and getting some high voltage audio by hooking up the audio transformer from an amplifier backwards. And amazingly, I was able to actually make the candle flame play music. It didn't sound very good because it was all on a treble. But so that was another thing. It's sort of, here's somebody inventing electrostatic speakers. And so there's no limit to what you can do if you just keep playing around with stuff. So here's, I haven't stopped doing this kind of thing, crazy combinations. So let's just, here's a combo. And you can sort of imagine what would be the next step there. And it's really fun to actually turn these things into reality. So So I had a lot of fun with that. Anyway, so after, I finally wound up going to college, and I thought one of the things I'd mention is one of the things I encountered in college was analog computers. So this guy is sitting in front of a huge patch panel and a whole bunch of knobs. And the patch panels give you connections, and the knobs let you change voltages and stuff. And the cool thing about analog computers is that, let me see, it occurred to me I could be showing myself, which this doesn't do unless I tell it to. And let's see, can you see both the screen and the slide? Need somebody to say
yes
if they.
Yes,
Okay, great.
both.
Thanks. Yeah, I lost my my faithful iPad that was telling me what everybody could see. So anyway, a couple of things. The main thing that's neat about them is that they're just live and doing stuff all the time, and I think that really got into my psyche about computing. If something's making a sine wave, it's just coming out, and you can run it to a speaker or an oscilloscope. And when you patch things differently, it changes right away. It's just live. And I had a real aha also during this time, which was I read this article about something called a bitrate multiplier, and it's sort of a neat scheme which allows you to essentially, the one thing about analog computers is they're not terribly accurate. I mean, the good ones are pretty accurate, better than 0.1% on everything. But you can actually represent analog values on a wire as a bit rate, a train of pulses. And so that got me excited. And then this was the way to generate them. And this was right about the time when, in my laboratory, I'd played around with various circuits, and I knew about logic and stuff. But all the logic circuits were big and complicated, or big and expensive. And right at that time, Fairchild was coming out with little ICs that you could buy for the NAND gates were like $1 a piece, and the flip flops were maybe twice that. And they were fast, for me. This is in the days when it was hard to get fast stuff, but these could run it in sub-microsecond times, which was as good as my oscilloscope would show. So I got fascinated with this, and I put together an analog computer. This is the biggest hardware project I ever did. It was 12 bits of register. And what I did was I fed the output into an incrementer. So it would either do exponential rise or exponential decay, depending on the sign of it. And that was kind of, that was cool, because you could then, by timing it and running that into a register, you could essentially get logarithms. And so if you did this for 3 numbers, it would multiply them all, and then you could flip the switch and it would go back and exponentiate and give you the answer. So I thought that was pretty cool and had fun with it. And a particularly neat thing was that I worked it so that the overflow of the count register happened at exactly the equivalent of 10. So I don't know if any of you still know how to work a slide rule, but slide rules have this problem in that sometimes the answer comes out over here where you can't read it. And that's what's cool about a circular slide rule, is it just wraps around. And so I had my little computer work that same way. So if you multiplied 5 by 5, you got back the answer 2.5, and you were expected to figure out that that's really 25. Anyway, had a lot of fun with that. The other thing, so this was all, I wound up building that thing as sort of a lab example in one of the first computer courses that Harvard ever had. that was not their strength. You went farther down the Charles River for that. But there was a course on Fortran that I took my senior year, and it blew my mind. And so that was my first encounter of real programming. And so as soon as I came out to Stanford, I got into a course run by Don Knuth. And Don wanted to find out how, what kind of programs people wrote. So he got from IBM, he got a list of like 20 or 30 programs, and we analyzed them. And I wrote an analyzer that would go through and stick statements into the middle of programs, so that get this kind of that kind of a listing. And these inserted statements would then tally counts in a big array. And then when the program quit, it would also insert before any stop statement something to call a finalization routine. And it would print out how many times everything got executed, and how many times if branches were taken true, and an estimate of how long it took. Just I counted up the arithmetic operations. So this is like performance analysis for the for the punched card generation. Anyway, it turned out to be something of value, especially some people were spending money and they didn't know why with their computers. So it was good to have a program like this, and I wound up selling something like this just as a little company. But also the serious companies also were concerned that about coverage. For those of you who don't know what that means, that's you want to make sure that whatever software you've got, at least it has been tested. Everything has run at least once. So it would do this trivially, just because anything that hadn't been run had zeros on it. So that got let's see. So then I was, in order to sell this program, I had to maintain it on a bunch of different, on IBM hardware, UNIVAC hardware, CDC hardware. So I would go out and haunt the various service bureaus late at night when computing was cheap, and make sure that my program ran on their machine. And one night I was at the CDC center in Palo Alto, and this other guy came in, and he was working on, he had a Fortran program for doing fast Fourier transforms for doing speech analysis, to figure out what the speech was. And I got to talking, and he said, "Yeah, I've just been hired by this new Xerox center, and they want somebody to work on speech recognition." And I said, "Well, that's interesting. If you want to run your program, want to see where it's spending all its time." So we had this nice conversation, and yes, he did, and he learned something from running it on my program. And we left. We parted as friends. But then I got a call about a week later, and he said, "Hey, I need some help setting up this system here at Xerox. Would you be willing to come up and help me do that?" So I had a lot of fun. I was there, and Ted Kaler, who also became a squeaker, were hired by this fellow George White, and we built him from a Sigma 3 mini computer. It's this big wall-sized thing. We basically turned it into a personal computer where you could enter stuff from the keyboard and see stuff on a display. So that was a lot of fun. But while we were doing this, I kept being more interested in conversations that I heard across the hallway, where this guy Alan Kay was talking about everything you can imagine, neat languages and education, and so on. So after a couple of weeks, Ted and I both went over, and we said, "What are you doing here?" And we got to know Alan, and vice versa, and got to talking about languages, and the whole this project to build a neat computer for the future, which was going to be the Alto. At that time, not much was known about it, but Alan was talking with other people there about the design for it. And in our conversation, we touched on various things about all the languages that we liked and didn't like, and Alan was saying how he was espousing all the virtues of doing things by sending messages rather than just calling functions. And so we said, well, what would it take to do a language like that? How much would it take to describe it? And he made the claim that he could do that in one page. So he went away and worked on that a lot. And he eventually, I think it took him, I think it was about a week. But he put together an outline of how such a language could work. And this is this was my transcription of what I figured I needed to do to make it work. And it's not good either, but we'll come back to that. But I'll tell you, sorry, I've sort of had to grab pieces from everywhere to talk about this easily. But so in here, I wanted to also give credit to, I'm talking about stuff that lots of people worked on. Alan Kay and Don Knuth are my real mentors. And then all these folks worked with me at Xerox and Apple, and then later Squeak at Apple and Disney. So we were interested in sort of the brevity of APL and the fact that it had garbage collection and workspaces, but it wasn't extensible the way we wanted it to be. And there's this problem of an n-squared problem of extensible languages, which is if you keep adding data types, you end up making them all more complicated to deal with the other types in the system. But that's something that message sending gets you around, because nothing can know about the internal parts of the other components. And then Meta was also a system, a neat compiler that we had all been impressed by, and we should have a talk on that sometime. And Lisp for its just beautiful simplicity, and Simula had a nice model for essentially doing simulation, and we wanted to be able to do that kinds of thing. So anyway, Alan came up with this new design, and let me and the way it worked was basically whatever you wrote as a program became a stream of tokens. Really simple. I mean, all you had to do was just read everything and turn it into tokens.
And it's very hard to read your slides because the video quality is very bad.
Okay.
Yeah, maybe you could zoom in a little bit.
Yeah. Okay. And the one other thing, just to know that there isn't much you need to know here, and I will read it to you as I point to things. But let's see. What I don't know if the simple zoom that I can do will do any good here. No, that's not helping any.
Maybe better turn off your camera if your upstream bandwidth is really low.
I will do that.
And in your, oops, now we don't, oh, yes, that looks better.
Is that better? Okay, good.
And you could turn on the presentation mode in the slide program, so it's full screen maybe.
Okay. Yeah, and we're almost done with this, but I'll, yeah. So let's see. I don't think I did the right thing. I'm not used to using. Let me just. There's very little that you need from this. Yeah. So here's an example piece of code, which is turtle go d times 5 and turn j times 90. And so you've got a stream of tokens here. and which constitutes a message. And so the simple rule in Smalltalk is you take the first token, which in this case would be turt, and you look it up and find out what it is. In this case, it probably would be a turtle, given the kind of thing we're doing. And then you take the rest of what's there and pass it to that object as a message. So then that goes to run the code in the class turtle, which in this case, you can see here, it starts out with a temporary variable named var and various state variables like pen, ink, width, direction, x and y. And then this little token here, it says, do you see go? And if so, draw a line of length that and return yourself actively. So this part here, this is pseudocode. So it would draw the line and then return itself actively. Oh, let's see, I forgot to say, draw a line of length, and this colon would go back to the message stream, which now says d times 5, and do the same thing for it. So that would look up d, and then it would look up the token times and 5 and come back with a result. And that would come back to be the length of the line, okay? And then when it returns itself actively this way, then it goes and runs through again and looks for, is it go? No, it's not. Is it turn? Yes, it is. And then do that. So that's how this language worked. It's incredibly simple, and you can do lots of fun stuff, and it's very easy to teach to kids. So that became my job, was to implement this thing. And I wound up writing a little interpreter, a virtual machine that had a stack and objects that grew from the other end. And then there's a global dictionary of all the objects and all the classes and the objects. And then in the same sort of memory load was the bitmap graphics for the Alto. So now let me just go to reshare my screen here. So now, let's see, this piece of the story I haven't told you, which is that after we all left Xerox, all of our Alto disk packs were about to be thrown out, and a couple of people managed to intercept that process. And so we have 120 disk images. In other words, the data from 120 Alto disks that all fits on one CD. And a couple of them were Smalltalk images. And but what I mean by image here, it was the 65,000 words of the Alto memory, just all in sequence. Actually, the first and second pages got put in a different way, but I didn't remember all that, but it's in the Alto manual. And I knew that, I had written this code and I had some listings, but nothing about the binary aspects of the listings. But eventually I looked around enough, and I went to a website that told, so another thing you don't know is that the Alto, it had a microcode emulator in it. I guess that was, I passed that slide, that took care of various things like updating the bits on the display, and it also had a task in it to tickle the memory, because the memory was dynamic RAM, and if you didn't run around and touch everything fairly frequently, the memory just went away. It just died. So that was another task it had, and then another task it had was to emulate the Data General Nova instruction set. So the Data General Nova was a really simple mini computer of the time, and one that looked like it would be easy to emulate in microcode. So I got that instruction set, and what you're looking at here is a little development system that I made in the Lively kernel that basically implements the Nova instruction set. So let me just show you a little bit, not that you care that much about the Lively kernel, but we'll just, so this shows all the code that was taken, that was needed to do this. And if you come down here and look, yeah, so can people read this, or shall I just, I'll speak this.
It's readable.
Yeah, oh, great, yeah. So the execute instruction goes and switches on what type of instruction it is. And it's either a jump increment or a memory reference instruction or an IO or an ALU instruction. And then that goes to do what you'd expect for the other things. So like the MRI instruction, it's either a load A or a store A. And you can see, this sets the register, whichever it is, to be the contents of the memory at that address. And every one of these execute instruction, every one of these returns the next PC that it should have. So for regular instructions, it just returns the next PC plus one. But if it's a jump or an increment, if it's a jump, then it will return some other thing, and that's how jumps work. It's very much like the the virtual machine for Smalltalk. If you look at that, the way it basically works is that each of the emulations returns the next thing that it should do. So let me drop that. So you can actually, if you reset this thing, you can actually step the instructions. So there it's doing a move and now a subtract that. This will clear register 1 and this will store it. And enable interrupts. This will move. So this will do a move from register 0 to itself and skip on a non-zero result. So we should see this thing either skip or not, Yep, it did. It skipped. And then here's some labels that I put in from my sussing around as to what everything was. So this now goes to the eval loop. This in out is where it had come when it saved itself on the disk. Okay, so this is where it resumes from. And so now we can just run it. Or we can go straight to show the Smalltalk view of things. And there it is. And it was, it's really fun to get to this point where suddenly it greeted me on the screen. Although it didn't look this clean the first time I tried. But so now this is how Smalltalk looked on the Alto. And typically we would, to make sure things were working, we would type 3 plus 4. That comes back 7. That's great. So that means that a whole lot had run for that to work, to print stuff and have the read routine work. And we always did this too. That tested all the floating point logic. And so then from then on, you could write significant programs in this. Let's do. So Smiley was a turtle. We put a fair amount of attention into making it easy to type, so things because this was being used to teach kids, and also Alan also wanted things to be sort of friendly and iconic. So that Smiley was the turtle that we used for doing all of our for doing a bunch of the turtle geometry education for kids. And so kids would pretty soon start doing, well, let's see, you could do You know what I did here? So I'm going to show you where you can get at this. Well, there's the link of it. It's part of a project I'm doing to put these things online. Oh, that's interesting. So this is a little bit out of the way here, but let me just get over here. Here's a window that is, it's connected up to this so that to save typing. You could, if you click, sort of do a slow double click after the alto character, then it will type that over here and do it. So there's smiley go 50. And then here's now turn 90 degrees and go 50 again. So you can see it's starting to work. And then these are the kinds of things kids would try. And then we teach them about do for, and then that would, and then you can talk to the kids about why is it over there? Because that's where we left it. So you get a sense of state from that. And reset the turtle. Yeah, that clearing the screen cleared the frame around this. I think that if I went here and said this. There we go. So anyway, we'll do a couple more of these, and then I'll just show you a little bit more about this app, and then we'll go on to the next thing. So this defines a method to make a square, and then there's a square with a side of 20, 3 more squares, and a for loop. Okay. And I won't do much more here, but let's see. Well, these are fun to look at. I'll do these two. We'll be done with them. And so here's a procedure that this colon angle says fetch the angle, colon n, fetch the number of sides and fetch the distance to go, and then for I to that number by that distance, go that distance and turn that angle. Okay, so if we now do this. Get that. So that's with 90 degrees. And if you do it just a little bit off from 90 degrees, it makes this nice, pretty design too. And then you can make another one going the other way. So lots of fun you could have with it. And built into this app, let me close that out then. You can, you can read a little bit about Smalltalk 72. That's not very useful, but the and stuff about the emulation. It includes all defs. And this was the bootstrap. This was the whole bootstrap of the system, and it starts out defining all of the simple little things like. There's that colon operation and return and quote, and there's the for loop. You see the for loop fetches its parameters and so on. And then it's all here basically, including atoms and numbers and strings and vectors, and then the control of the mouse and stuff like that. And then there's also a link here to get if you want to read all about it. There's a link to the manual that Alan and Adele wrote about it. So and come back here. Oh, I guess you probably didn't get to see that when I did it. I'm sorry, that went into another frame. So that's what I wanted to say about Smalltalk 72. No, it's not all I wanted to say. So partly I love the system because it's really simple, but it also Alan never did a rigorous job of, we don't have a rigorous definition of the interpreter. And my code is inscrutable old Nova code. And even what I did in this system, it's still Nova code, so it's inscrutable. But what I've always wanted to do is to go back and write this in itself. So when we did Smalltalk 76, one of the neatest things about Smalltalk 76 was having the definition of the interpreter be in class context. So you could see how the virtual machine worked just by repeatedly executing context step. And if we were to, so a weakness of Smalltalk 72 is that it did have classes, but classes themselves weren't classes. They were a table, so you could put a leech on them and look into them. But the contexts were also not real objects. Again, you could poke around in memory, but there's nothing to work with. But if you did a Smalltalk 72 that had contexts, then you could do the same kind of thing, and you could write this eval that says, go chase up the global chain and find out the value of the next token, and then go find the code from its class, and go down and start looking for the next to match the next token. So you could do all of that in Smalltalk 72. It would not be 72 anymore, but sort of a redux of it. So I have an active project now, and I've done a version of Smalltalk 72 that's all in JavaScript, and that has classes and most importantly contexts as real objects. And right now they all run in JavaScript, but they have outriggers so that they could hold Smalltalk code to run themselves. And my goal is to then be able to run Smalltalk in itself that way and have it be usable, because it turns out that although Smalltalk is terribly inefficient, as you can imagine, the one that I did in JavaScript runs about 700 times faster than Alto Smalltalk did. So I think it would still end up being faster than Smalltalk, even if it was running in itself. And it would be fun because you could sort of reduce down to seeing what the minimum number of things that needed to be primitive in it would be. So I thought that would be fun. And I'm gonna, if you haven't figured this out already, I've got this a website called the Smalltalk Zoo that's at the Computer History Museum, and that project is talked about there, and there's links to its code. So now I thought I would just go on and sort of show, show a few of my my favorite little things to look at, and then we can chat. I'll try to be done in about 15 minutes. So let me get to reshare my screen here. And let's include audio. Yeah, so the first thing I thought I'd take a look at is, so it was really fun doing Squeak to be able to redo graphics sort of in a simple way. And let me jump to a project here, which is fun with Morphic. So, Alan, I still remember we were driving, I don't know exactly, driving out to lunch, and we had text working, but Alan wanted to do documents, and he said, could you make it so that one frame of text can link to another? And I said, yeah, I ought to be able to do that. I can see how to do that and have it flow. Yes. And he said, and while you're at it, can you do this thing that they do in Word, which is to have it run around objects? And I said, oh, well, got to think about that. So I figured out how to do that. And so then he sent me off to work on that, and I worked on that. And while I was at it, we had pretty nice curves in the system, so I made it so that it could fit inside of a given curve. So this was the demo I gave to Alan to let him know that I was done. So these are three containers of text: the blob in the upper left, this little sort of tube in the middle, and this frame down in the lower right, and it's got an occlusion in it, and so you can sort of let me do this. Let's see. Yeah, so I can drag this occlusion around. You can see how our spirit from the beginning has always been to keep things live as much as possible. And then this tube, the text that comes out of here, well, it's a little bit hard to see. But if I take this curve and move it around, you can see that as I make the curve longer, it's pulling words out of the bottom frame. And similarly, if I go over here and change this, the curve of this blob, it either puts more text into or takes text out of the tube. So that was fun to do, and there's a lot of other play here. You can, like, if I take this magnifying glass, that's also let it work. You can sort of see that this is it's looking through the text at a moving background. It's kind of moving background. And you could have a cowboy with cactuses going behind it, that kind of thing. So that was a lot of fun. And let me take the nicest demo I know of some of that stuff is to go to this project. So this is, I'm looking at one Squeak image that has a whole bunch of projects in it, obviously. This is what Alan wanted to be able to do, which is to, do serious text, and be able to have an occlusion in the middle of it, or, or somewhere even like that. A fun thing that he did that I hadn't thought of doing is to, let's see, so we can get a viewer on this ellipse. So this is all running together with eToys. So I could take this this command here, which is tell the ellipse to go forward by 5. Well, that's not very good, is it? You can't see what I'm doing. And then turn by 5. And then I can make that happen. And let me close this. And in fact, I can make it happen repeatedly, or I can tell it to just start ticking. And then and I can pick it up while it's ticking. Hey, let me down. And I can drop it over here. So we had fun doing things like that. And this I have to say, the context of working on that project was so much fun. A quick other thing. Oh, I'm going to skip. I was going to show you. I had this neat way to do the game of life in using just BitBlit. but it turns out that it does nothing over the as a shared screen over the network. Just doesn't keep up at all. I was going to show how blindingly fast it goes with 1 million pixels. But there's one design that's kind of fun though, which get back to previous project. Oops. What I really wanted to do was to go to and so a while after we got started with, after I got Bitblit all working with color and all the different color depths, we had this off-site meeting in New Hampshire in which it suddenly occurred to me that with just a little sort of a like differential analyzer on the stepping of the source, you could make Bitblit do rotation. So I had a lot of fun with that. Yeah. And so, and this is sort of the test for that, which is, and so as I move my mouse, let's see, got to make sure that you can see what I'm doing. As I move from left to right, it changes the direction of the rotation, and then it takes and it keeps, and then it rotates that and rotates that. That's what's going on here. And as I move up and down, it moves by a greater amount or a lesser amount. And it gets really interesting if I move my mouse down toward the center, then you get these sort of infinite patterns. And it gets even weirder if you go beyond, then it starts to essentially magnify noise in this very pretty manner. We spent hours just looking at these things. It's kind of fun. Let's see. So the one other, in things that I felt really good about in this system. Let me just jump to that. See if yeah, magnitude. So there's something about well, there's lots about object-oriented programming, but something great about sending messages, which is if you compile a method with that's a message-oriented method. See, this is find the minimum of two numbers. It's min colon a magnitude, and it says if self is less than a magnitude, then return self, otherwise return a magnitude. Very simple piece of code, and we can compile that. And here's the byte codes it generates, and it's very few byte codes. Push myself on a stack, push the argument on, send the less than message, jump if false to return the temp, otherwise return yourself. So that's a very tiny piece of code. But what's cool about it is that since these are only messages, it will work for any argument that understands the less than message. So we can go and look at the inheritance, the hierarchy of magnitude, and we see all of these things can run that exact same code. Integers work, of course, floats work, fractions work, dates, months, weeks. So those same 8 bytes work for all of this, and that allows you to build quite a compact system, more so than you might expect. And Squeak was quite compact. We worked really hard at doing that, and maybe harder than we should have on the storage format so that it could be compact, because the system that it was grown from was a a 16-bit system with an object table, and we wanted it to be a 32-bit system with no object table. So, and I felt sheepish about this, oh no, it's going to be a space hog. So we really worked to make it be compact. And I'll show you an example. Let's see, what's the easiest way to do this? I'm going to share my screen again. Eventually I'll learn 8x8. Chrome tab. And now I'll hope that I get the right one. I think this is it. Nope. That's where we, oh yeah, there we are. So this is, I went through the Squeak system and reduced it to just, well, let's see what it is. It actually says in here, first of all. I got it down to about 200 classes, I think. I'm sure it says here. Yeah, there it is. (202) classes. And threw away all the sources that almost from the beginning with our Smalltalk systems, we've made it so that they could decompile if they didn't have the sources. But I did a special version here which stored a compact version of the temporary names. So this actually includes the source for the temporaries. And this whole image is about 650 kilobytes. So, which is just about the size of the Xerox released Smalltalk image. So I felt really good about that. And let me show you this. If I run this little loop, it'll take just a minute. And what it's going to do is to report back how many bytes of source code are decompiled from what's in there. And so in this image, it decompiles, it's got in it 650K worth of source file, but the image is only, 856. But the image is only 650 kilobytes. So it's like having source code compression with an integrated development environment thrown in for free. And it's sort of, it's all here waiting to, let's see, what can you do here? We'll get it here in a minute. Can set the display depth and go up. So it's got all its color model in it, and it's got a full browser, and you can decompile the code, and so so everything's in here, including stylized text and the whole development environment. So I thought I felt good about that compactness and the compactness of the underlying system that we designed. And I think that's where I'm gonna, oh no, yes, and now I wanted to, I saved my favorite thing for last. And let me just, let me do this. Share screen one more time. Chrome tab with audio. So we did a whole eToy framework. This was the sort of the beginning of tile scripting, or we certainly, it was, the eToy system was what was the parent of the tile system that became Scratch, because John Maloney was part of our group. He worked on it a lot. And Alan had this design for something. He knew an artist who would draw this drawing. It looks suspiciously like a place in Disneyland. And these characters, these characters are musicians, and they're movable. At least some of them are movable. And you notice that as I move them down, they get close, they get bigger, and I move them up, they get smaller. And down below is a MIDI controller for playing this score. And if you look at it, this guy is the clarinet. And if you look at the slider on the clarinet, you'll see it moves left to right. And if I move him up so he's farther away, the volume goes down. So that's all done with eToy scripts. This is Alan when he's seriously programming. And so you see that, let's see, there's the clarinet bear, the Clair Bear. And it talks about the Clair Bear's range. And this makes his scalar ghost, which makes him bigger. Down here, set the scale factor to be the Clair Bear scalar. And so you've got that for each of the clarinet, the trumpet, and the trombone. So all of that's sort of ready to work. And down here also, just thrown in for free, is an editor for the timbre that you can. So this is all doing squeak music synthesis when it runs, and I'm just going to start it up. And but I ought to at least just show that works. So you can. And you can change the timbre. So what's the weird one to do is ratio, so that you can tell that things have changed. Not that you'd want to do that, but yeah. Oh well. So anyway, let me close that and play this. So this is tracking through a score, reading MIDI, synthesizing 6 instruments on the fly while controlling their pan and volume in eToy script. And I apologize for what I did to that, but at least you know. Maybe I can clear it while it's running. That would be a feed. It's particularly bad. We fixed the clarinet. Oh, and you get to see, of course, that that's being done in real time, while it's running. The only way to go. So I think I'm going to stop with that and open things up to questions and discussion.
Yay! Hooray!
So I suggest people type in the text chat to form like a speaker queue. whoever wants the mic can open the text chat in the lower left and let us know, and then yeah, anyone? That was awesome, Dan.
Oh, Stephen Pope has raised his hand. Please ask your
Okay.
question.
Okay.
Yeah, well, I didn't expect you to call on me right away. No, Dan, while you were presenting, I wanted to just say, speaking as a guy who's almost as old as you, I mean, my beard is almost as white, and just you've made incredible contributions, and you didn't even mention little things like BitBlit. Well, there's another white beard. I see Mark Lenzner. But your contributions are myriad. But on the other hand, I have to say, my question would be, what has gone wrong with Smalltalk? I gave a lecture presentation much like this a little while ago to the England Smalltalk UK group.
Oh, yeah.
And ended up, unfortunately, just realizing I'd spent a lot of the year trying to port my code to Faro and Modern Squeak and Quis, and just saying, damn, I wish just Smalltalk 80 was there, or I wish VisualWorks was cheaper and easier. So I guess I wanted to laud you and then poke you in the same question.
Yeah. Yep. Well, let's see. Squeak's free. So there's that.
Squeak is seriously bloated. I'm sorry to interrupt, sir. How do we handle bloat? Who's going to come out with Squeak minus minus?
Well, somebody has to take responsibility for that. You know, I mean, that is something that I did, and others in the group did. But we would, we would. It sort of breathed. You know, it got bigger and bigger and bigger, and then I'd go through and sort of try to make sense of what needed to be kept in the kernel and put the rest out. It's a tough one. People want. There's a part of your answer is, I think, that some people are trying to make a living, and expectations are high about what they need to do, and how many current day features need to be lashed into the thing to make it competitive, or what people expect, and it's hard to do that without a certain amount of bloat. Same thing happened with Lively Kernel. It started out really simple, but you do have somebody has to have that as their agenda, and that was the wonderful thing of working for Alan. I mean, Alan basically he wanted a vehicle for doing educational software. And other than that, we could do what we wanted, and that included keeping it small and clean. And so I don't know. It's not easy to answer your question entirely, I think. But somebody has to want that, be paid to do that, or have so much fun doing it that they do it anyway. I mean, that's what's happening with me with this Smalltalk 72 thing. I mean, it's just fun. That's all.
Mm-hmm. And you should check out Quiz. Juan is on this call, which is a
that's right,
derivative of Squeak, and it's beautifully small and fast. You really might like that.
I love it. I wish we had MVC. So I'm going to say again, let's get together a group to get rid of Morphic in Quiz. VC or something like the wrapper framework from VisualWorks.
Squeak still has MVC, so I bet that could be ported to Quiz.
Yeah, Stephen, you should port this.
I also just want to point out there is VisualWorks non-commercial if the price is an issue.
Yeah, that's what I work in now.
Yeah.
I've been trying to switch back and forth between Squeak and VisualWorks.
Do we have another question?
I had my hand up.
Oh, please go.
Yes, Mark is next in the speaker queue. Yes.
It's actually sort of not really a question. I'm Smalltalk Zoo is just a delight, especially as someone who worked on some of that early stuff.
Oh yeah, good.
Wow, that was so sweet. So I was looking at all that. I did want to let you know I have an original set of the Apple Smalltalk release discs. If you don't and you would like them,
Awesome.
I noticed that the source file is not in the emulation, so I have that disc as well.
Oh yeah, yep.
I have no way to read these discs, but perhaps someone does. So.
Yeah. Well, the unfortunate thing, the last generation of the Apple Smalltalk, unfortunately, got changed so that it used the toolbox. It's not easy to do, like get to the disk sources. So yeah, and I don't have any of the earlier ones.
I see. I don't know that I do.
Yeah.
I admit I was the source of that code change since I wrote the toolbox access layer.
Oh yeah, but I think Barry put in
Barry
all the
put
ones with graphics and stuff. Yeah. I need to credit you also with Mark did a great spelling corrector for this. And,
I'm sorry, at the risk of telling a tiny quick tale, there's a little more to that than that. So I was fresh out of college, and through a crazy story that I will not tell, I managed to land what could only be my dream job, which was to work for Larry Tesler with Dan Ingalls and Barry and Yu-Ying Chow on Smalltalk at Apple, which was it's like I died and gone to heaven. And so I showed up there, and like really Dan was working on the garbage collector, and I guess I did some work with that with him. But then he set me this big task. He was like, well, there's no spelling corrector. And since I wrote it at Xerox PARC, I cannot write it. So he tasked me with writing a spelling corrector without giving me any hints. It was amazing.
Yep. And you did a better one.
Well, it was not bad. Yeah.
Oh, by the way, you should, for folks who don't know, you should find out about Mark's glyphic script, which I thought was beautiful because it had a lot of the sort of beautiful, architecture essentially as self, but was small.
All right.
Self. It's what Dave Unger did was amazing, but it was prohibitively large. At least when it was being developed. I mean, nowadays we don't blink twice about things that are 100 megabytes. But so glyphic script was very cool.
Yeah, it was an attempt to be. I couldn't have Smalltalk in the environments I wanted it. It was hard to get anyway at that point in those days, early '90s. And so glyphic script was a very, very, very small. It could actually. We actually had a version that ran in a satellite pager. One of the papers, like only had 32K of memory. Thing actually ran, but yeah, we had a development environment that ran there. It was very similar, very, very much inspired. I have a big, wonderful pile of notes to speak to Stephen Pope called "What's Wrong with Smalltalk," which was like the things that I was miserable about in Smalltalk, or that I was like and somewhere I have that piece of paper. I should dig it up as historical artifact of what I thought Smalltalk and fix it. So that is somewhere. It's a glyphic script. Here, I'll write it here. And you can actually, the docs are online somewhere. The source code is online somewhere, but it doesn't really build very well on anything anymore. So,
well, we could fix that.
Probably. I'll throw links in chat when I find them. But anyway, and. Yes, and also just Dan, as always, thanks for launching my career as a programmer, because that was it was the best internship ever. Well, it was an internship, but it felt like a journeymanship ever.
Great, it was a pleasure. Yep.
Thank you. Lawson has a question.
Yeah, hey Dan, very pleased to meet you. I was wondering, Don Knuth got the Apple to release the source code for quick draw regions. Had you ever wondered what it would be like to be able to put regions into BitBlit?
No.
No. Okay, well, there's that.
But no, as what Bill did was an amazing job, and no, that might be something worth doing. I know that we did look at doing something like that. Oh, geez, what was the work? But I was no longer so much in the group. Ellen worked on that at Viewpoints with, gosh, who all worked on that? I'm not sure, but and then also what Andreas did with Balloon did a great job of outlining and stuff. But it's not really a replacement for what Bill had in QuickDraw.
Yeah, well, I chatted with Juan Vilutek a little bit about how to incorporate it with his Quis vector graphics. He's not sure it's possible. I think it'd still be useful for like clipping windows and things like that.
Yeah. Yep.
Also clipping within, pictures, which are bit-based, not vector-based.
Yeah.
But I've been trying to puzzle it through. It's very straightforward code. The problem is that Bill Atkinson spent most of his time compressing it down into nothing. So it's kind of hard to figure out what's going on just because it's like, the most optimized thing you've ever seen.
Right, I bet. Yep.
So I was just wondering. I'm still trying to figure out how to do that. And if I do, I'll certainly let you know.
Oh, that'd be good. Yeah, that could be something to talk about.
Oh, thank you.
Thank you. Next is Tim.
Okay, assuming this thing's on. First of all, Dan, thanks along with Alan and the rest for providing so far 40 years of amusement and career, or very nearly 40 years anyway. And I'm just going to sort of have a minor riposte to Stephen's worry about bloat in Squeak and so on. I mean, yes, it's a lot bigger than it could be. It's currently got all of eToys in and a whole loads of other stuff that people have thought useful at times. And certainly Morphic could be shrunk quite a lot. But honestly, it's still smaller than most of the images that we take with our cell phones these days. So I really don't see that as being a particularly big issue. It just doesn't seem worth spending huge amounts of effort on when we can run a dozen or more copies of Squeak on a Raspberry Pi at the same time without any problem. Effort where it's really needed.
Oh, was that Stephen?
Well, in terms of learnability, you may remember the original old school Smalltalk browsers like Dan was showing us, and especially what we call a 6-pane browser, where you parsed out the class category names into a 2-level hierarchy, oversee the whole system without really scrolling. Because at the very left, the topmost pane, you had collections, magnitudes, graphics, etc. And within each of those, you had a sublist that was
I'm familiar with it.
Items.
You only need to set a preference and you get that in Squeak.
Or anything, and you've got Balloon and Metacello and all these things that don't even mean anything. And there's 100 or more top-level items, so it's not learnable. And the first law of reuse is if you can't find it, you can't reuse it. So I like the old school systems.
First of all, there's a preference to have a 6-pane browser in Squeak anyway. So you and there's a bunch of stuff that you could take out, but I stand by the point that the image size is just not particularly an interesting thing anymore. And yes, I'd like it to be smaller because I'm an old fart like you, and I'm used to remembering back to the days when a megabyte was considered a vast workstation. But we've moved on.
Well, you're not alone in wanting a small, learnable system. I worked with Alan Kay a few years ago, who basically stopped using Smalltalk as Smalltalk. Even in Squeak, he basically only used eToys, not the actual Smalltalk language. But he told me that the most fun he had with Smalltalk lately was using my little Smalltalk 78 VM that I built with Dan in JavaScript. And so he said Smalltalk 78 fit in his little head. And if you know, Alan does not have a little brain, but that was like his comfort zone with, I don't know if it's less than 100 classes or so. And it's really nice to work in.
What's happening?
Come again?
Yeah, I get it. I mean, in the old days, I could have.
Wait, you just muted yourself, I think.
Oh, sorry about that. When the phone rang, I muted everyone but Vanessa. So people will have to unmute themselves again.
Okay, I was just going to say that I remember back when I was still living in Britain, I could have recited you the entire source code of Smalltalk ATV2 without having to look at anything. So, yeah.
Yeah, and when I'm introducing Squeak to newcomers who are already familiar with some web development, I am trying to reduce the cognitive load as much as I can, in addition to just the raw space of it. So I think it is very important to be able to unload things and reload them and unload them again with no hysteresis each time. So I'm working on that.
Yeah.
And part of the problem with the giant image is, the hidden dependencies can creep in unless you do this continuous unload, reload, build an image from the start. But another problem that, one of the nice things about Smalltalk is, I hate using the term integrated development environment. I like saying a residential development environment. All the tools that you want to program are there in the image. The compiler, the text editor, the spell corrector, and they appear in the class browser along with things that you really need to learn as a beginner, like collections and streams and numbers. So, in a conventional system, all that stuff is in a different tool set. And in terms of like easy things for learning, I always thought it'd be nice to have an additional kind of organization, maybe like classes by difficulty level. So you can just show me the beginner classes, show me the inner, and sort of gradually have a browser that gradually reveals more and more of the system.
Mm-hmm. I've seen browsers like that, where
Adele and I did that first version
things
of
are revealed. Mm-hmm.
What was that, Tim?
Adele and I did that idea of a browser that gradually revealed more and more for the first versions of LearningWorks back in the mid-90s.
Mm-hmm.
It worked quite well. Several thousand students went through college courses using it at a dozen or more universities.
Yep. More questions?
Mark has his hand up again, I think.
Yes, I have a question for Dan. So a lot has happened in programming languages and programming environments in the intervening 40 years. And I'm sure many people on this call would say, there's so many things we had in Smalltalk that we still don't have in any of these other environments. But I'm wondering, from your perspective, there has been a lot of motion in things like functional programming, motion in prototype bases versus class base, as well as more subtle changes like the sort of developments in C++. But Smalltalk is wonderful, but what do you, ignoring where Smalltalk goes, what do you see from that intrigues you, or you think is intriguing?
Dan, you're muted.
You're muted, Dan.
Thank you, folks. I haven't done my homework. There's I have a pile of books that I still want to read, and a number of programming languages that I still want to dig into. My sense is that I would like to do more with Haskell, and maybe a couple of others. The thing that is hard always to get over is, you need an intuitive model. I mean, Lisp is incredibly beautiful, but some of it is just plain hard to think about, if you don't, if you're not wired that way or didn't learn that way early on, and now there are things that have been put on top of Lisp, other Lisp systems that make them much more practical, and so you don't sort of think in the kernel way when you're doing it. I think Lucanini has done some really neat stuff that's kind of a mixture of Haskell and JavaScript to sort of hook up to everything else. So I'm not sure exactly how to answer you, Mark. I've been in this wacky world of JavaScript, which is just like down level from what I'm used to, but we managed to, in the lively kernel at least, make it feel similar to Squeak in many ways. But I don't know. I'd be interested I think that would be something that would be nice to talk about in this group as time goes forward, which is the sort of the neatest little kernels that people know of, and it has to be both a neat kernel and a neat environment. Enough of an environment to be fun or to do something powerful with. So I don't know. What's your feeling, Mark?
Well, I admit I'm colored by 30 years of building larger software systems, and one of the things that I remember missing in Smalltalk is support for larger systems and their compartmentalization. That can be difficult. I know there's later module stuff, which is after my time in Smalltalk, so I don't know it, but it is there. I have come to love really, really strong typing. Some of you may know that I was deeply involved in the Haskell ecosystem for about a decade. And I've also done work in Elm, which is another similar thing. And I have come to what I miss from Smalltalk is that certainty that you get with really, really strong types. That when you say something, there's a very, very strong guarantee if it compiles that you've said something strong about this piece of code. And in Smalltalk, the very same token which allows less than to work polymorphically is also the very same noose which can hang you easily later on. And that can be and so figuring out how to navigate those two things would be a very interesting exploration to go on.
Yeah. One ought to be able to have strong types when you want them and not when you don't.
Okay, Merrick's next.
Hi, Dan. What I've been wondering for many years is we're moving in the next 30 years, and I want Smalltalk to be alive for the next 30 years. And the best thing to do there, I think, is to make it from going from a sequential environment to a massively parallel executing environment, and then we can scale into the future. But how would you approach a massively parallel Squeak or Smalltalk, I should say?
I bet some other people here have thought more about that and would have things to say about it. I do think about that some, and with Lively, although we got more into things that were internet connected, but we didn't do it at the fine grain that you'd like to use vast numbers of processors. What do people have to say about that?
Okay,
Giselle has something to say about that.
Yeah, we're working on it.
That's right. Yep.
There's an interesting language coming out called Pony. It's an actor language, and it has a type system for references and variables. So rather than the types denoting the type of the data value, it denotes something about the actual variable reference. And it's an interesting system. It it's kind of morally a lot like Rust's borrow checker, but the idea is it's a pure actor model, and it enables you to safely share objects amongst threads without doing any of the problems with high levels of concurrency costs like races.
Giselle, do you want to say one or two words? Or not to do?
I just mentioned that this has had a lot of research. There was a computer at MIT called the Jelly Bean machine, which they built with 1,000 processors. They had a concurrent Smalltalk, which had Lisp syntax. MIT is a fan of Lisp, so they thought that it was a nicer syntax. But the semantics was Smalltalk. So this was 1990 or so. Then there was also David Unger's Roar VM, which other people also worked on. So it ran on 56 processors, had onboard for the PC. So it's a very hard problem because actually recently Stefan Marr has his PhD thesis was about one way to attack the problem. But like Merrick said, if we don't solve that, then we're going to build hardware that our software can't use.
Cool. Okay, I think we have some more people in the speaker queue.
Yeah, Juan.
Juan is next.
Yes. First, before anything else, thank you, Dan, for all the gift you gave the world and me, and the incredible way you shaped my professional life for decades now. So thank you very much for all that. I want to go back to an area we don't touch much, and it's the original inspiration of the Smalltalk effort that was the Dynabook vision. Alan's Dynabook vision was using programming as a new medium for communication of knowledge, okay, for learning, for experimenting, and documenting and sharing knowledge. And Smalltalk started as an effort to make that real, and then the Smalltalk project turned more into a development environment and language project that was very much needed. And then not much happened with that original vision. The original idea was to use Smalltalk as a Dynabook language, the language in which to express knowledge. Then the next thing at least I know about is eToys. That is a completely different language for doing that kind of activities, using Smalltalk only as an implementation language. Maybe Scratch goes back a bit to be closer to Smalltalk in that regard. But and today, another remark is that there is a movement, a world movement called Open Science, Reproducible Research, and all that stuff. And many people who know nothing about Dynabook or Smalltalk are becoming aware that scientific research should be reproducible and understandable by other people, not just the author. And people doing that are using mainly Python. That is a very poor language for doing that. Way worse than Smalltalk, and I guess way worse than what Alan would have hoped for. So the questions are two. Any historical remarks on making the Dynabook real that are not so well known as those I told you, if you can share? And on the other hand, if you have any thoughts or advice for people wanting to make that real eventually?
So I don't know about plans in that direction, and I'm not sure what Alan has been up to in that direction recently. I don't think he has been so much. I know that Alan continues to care about and be passionate about education, and this doesn't really speak to your question, but I had a back and forth emails with him around the turn of the year, and lamenting the political situation in this country that to me is greatly rooted in education. And he, at the bottom of his message to me, I'm going to read this to you because I mentioned also about this group. He said, if something comes from your new Smalltalk group, it should be a better approach to children, science, and computing. And as usual, this will lead to something better for adults in many ways. Just thought I'd pass that along.
Thank you so much.
But I don't know about other work on hardware, and is it just a better pad? Is it 1,000 processors in your phone? I'm not sure. What's your feeling about what's needed? I mean, I think the stuff that's needed in education is pretty basic. Maybe even doesn't need a machine sometimes, I think. But
well, I am more thinking about not education but scientific research, and a medium for communicating ideas and knowledge for adults. I mean, most very smart adults who have stuff to say, the best way they can do it is with spoken word in a language like English. And as you are perfectly aware, many ideas are better shown in other ways. I still hope that someday there will be better ways to express knowledge than natural language.
I got started on a project, but it's easy to get started on a project. I don't have anything to show for it, but this was just before the plug got pulled in our San Francisco group at YCR, and it began as what I wanted to have something that's like a lab notebook, where you have you've got stuff that you're writing and you've also got code, and it's but it would include all of the wonderful features of repositories like Git, so that you'd always go back and run your old code, and somebody else could go and make changes in your code, and it would never change the original, so that it would remain a legally valid thing, but you always would copy on write, and have that kind of thing, so other people could contribute and it would just be attached, and pick up your work that way. But I never got to take that very far. I don't know if that really answers the question. But.
Thank you very much.
David Simmons?
Wait.
Oh.
So that would almost be a perfect end, especially Alan's quote. We do have one more question from David. But I would say we kind of want to have an official stop of this meeting, maybe at the top of the hour. And we want to invite suggestions for talks. So Craig mentioned at the beginning that we always want to have like some lightning talks, which is like a 2 to 5 minute thing someone is excited about, and that would be at the beginning of each of these meetups. And then a deeper talk, a longer talk by someone like Dan did today. And we're looking for people who would be willing to do such a talk. But also, if you think of someone that we should try to invite here to give such a talk, so please let us know. Craig set up a Twitter account where you can reach us. I'll let Craig say what that is.
Yeah, if you look on Twitter for California Smalltalkers, you'll find us, and the handle is Joy of Live Coding. So yeah, please give us feedback and volunteer.
And this will be monthly, every second Wednesday.
Yeah, we'll be doing second Wednesdays at this time.
Okay, David. David Simmons. Are you muted? I cannot hear you.
I see a ghost icon next to David Simmons' thumbnail picture. Maybe his connection is having trouble.
Oh, okay.
In the meantime, maybe we could go to Mike Klein. You raised your hand.
Yes. So this is more appropriate for the more general, but since Dan mentioned it earlier, I too feel that kind of technical loneliness. And I've been reaching out to a lot of my old Smalltalker friends. That's how I recently reconnected with Craig. Thank you. But so I'm wondering if anyone knows of like a group like an IRC or something where people just who like Smalltalk just go and hang out. No scheduled time. When I feel this way, I go to the Haskell IRC because there's always people there. I go to the Smalltalk one and it's just dead. I just wondering if anyone knew of anything like that. Maybe we need maybe we need to all start just hanging out in the Smalltalk IRC.
There's a very active community on Discord for Smalltalk.
Oh.
So there is a Discord server for Dolphin Smalltalk. There is a Discord server for a kind of Smalltalk reunion. There is the Faro Discord server where a lot of people meet, exchanging regarding Faro and also off-topic things or VM stuff and other. So there's quite a good community and lots of people are reachable there.
Oh, perfect. I just recently got on Discord, so it's kind of new to me, but nice to know that's where the action is.
Yeah.
It is good to know.
See, let's try again with David.
Not hearing anything.
Maybe Lawson has raised his hand again.
I just wanted to ask Dan if there was any updates on Croquet and how Croquet might eventually be used to host things like this.
Oh, so actually you should be asking Vanessa, because Vanessa's actually working on the closest to the follow-on.
Okay, well, Vanessa, are there? How soon could we expect Croquet working for something like this, and how could we get it ported back to Smalltalk?
Porting back to Smalltalk. I don't know. The current, with the latest Squeak version of Croquet works. Nikolai Suslov did a forward port from the old Croquet version to the current Squeak version. So it's working. If you want to help him out developing that, it's at the, what's the website? Kresťanstvo.org. That would be the latest Smalltalk version.
Yeah, if you can
type
add
that
that in, that would be great. As far as what Merrick says, the older Smalltalk the older croquet doesn't have the new handling of reflectors and whatnot, as far as I know.
I'm not sure what you're referring to.
Oh, in the comments, Merrick says that we still have a working croquet and squeak, but the newer version of croquet it does not do things the old way, as I understand it. There's tea time has been revised and updated, I thought.
Are you referring to what we're doing as a company, or which one?
Well, I'm just referring to being able to broadcast, because Andreas Raab's solution was islands and hosting the server within the image with Croquet itself, whereas my understanding is that you're using external reflector, whatever they would be called, not servers, whatever's to rebroadcast things.
Look at the Open Quack. What is it called? Open Quack. That's the another version of Croquet. It's what Teleplace built, and that's using hosted reflectors. So that's a Smalltalk thing. It's Craig knows that. Is that open source? I think it is.
Yeah.
Yeah.
It is open. It is open source. I thought that Quack's stuff had become proprietary, so my mistake.
No, they open sourced it when the company folded.
I was not aware of
and
that.
There's still a commercial version that Ron Tattlebaum is doing, still running the same Squeak code, or more modern version of that Squeak code, and it's still a company that has clients, and it's working. What we do. What?
Oh, I was just going to say, as long as we're talking about Croquet variants, there's also the Open Cobalt branch, and the LA Smalltalk Users Group actually held a meeting in Open Cobalt once.
Mm-hmm.
So.
That code is still around, yeah.
Yeah.
I don't know if anyone is working on that. I am working at Croquet Corporation now, and I actually wrote the whole thing in JavaScript, and it's running in JavaScript. So we're trying to make money of that, and yeah, not using Smalltalk for that anytime soon. Okay, that was that question. Who was next in the queue? Thorsten, I think.
Yeah. First of all, I also would like to say thank you for all the work you did for Smalltalk in general. And my question would be related a little bit to the history of Smalltalk also. A lot of things that we have in Smalltalk, and this is what I mostly enjoy, is that you can introspect anything, you can change anything, and yet you have objects all the way down on a lot of places. And Smalltalk also has the meta level and the meta classes, for instance. Sometimes people think it's just there, let's say, to be unique in having objects also, because if you have a class, then the class has to be an object as well, so it has to have a class again, and so on. First, a question: how did that evolve? So, what was the history really in introducing them and using them? And the second thing is, what do you think about the let's say the development of these meta facilities of Smalltalk? Because this is for me the most underrated thing at the moment, because we stopped with, let's say, we had objects, classes, methods, we had categories, instance variables as strings, but as dead strings. I mean, for instance, in Faro, they are at the moment were changed to slots, so you have real objects, so you could put something onto the on an instance variable to say it's not only, let's say, a name or a string with the type, but you could say this is a cardinality or other. And to me, this is also a little bit a sad part of Smalltalk, because it stopped at that level. It never introduced real packages, which had led to trouble in modularity. It never introduced really environments, except the Squeak image parts that we had back in time, or other meta objects, like for instance a change on a code or on data. This could be also an object, but it never went into that in some things. And to me, this is where Smalltalk really has still a lot of power, because other things, I mean, have progressed also in other languages. They tried to follow, or they mostly they are, let's say, successful because they have had the possibility to grow an ecosystem. But for me, these are two things that I would like to know a little bit about your opinion. First, okay, what was the meta thing introduced in Smalltalk, or what was the history behind that, and what do you think about its potential?
Let's see, I can answer a part of this, but it's not your whole question, I don't think. The introduction of meta classes was for a relatively low-level desire. It's just that we needed a way to have instance-specific behavior for classes, and the only way you do that is make them be instances of something else. And it conveniently gave us a place to put what everybody else puts in as static code. So the stuff you want to do about initialization for a class, or the functions that are local to that class, to that sort of kind of class, you can put there, and it's a nice place to have them. But that's not the sort of deeper kind of. I mean, it's one deeper thing, but it's not part of a whole deep hierarchy that you might want for doing that. And there's lots of other stuff that you can imagine doing declaratively. And I have a trivial answer to that, which is, as regards to me, I sort of left that community. So I didn't keep doing it, and didn't have the wonderful umbrella of Alan's project for quite a while, so I didn't work on it, in that way. And even there, well, it was a matter of what we were all interested in that would keep us motivated. Mostly, the big goal through doing Squeak, which didn't add new things in that way, was Squeak is a vehicle for educational software, and it served well for doing eToys for sure, and other stuff. I mean, it certainly helped Croquet, and a number of other things built in it. I feel really good about that. But yeah, a more reflective, more declarative sort of system. There are lots of directions you can go. I mean, we've talked about types, and there's a whole deep type, question. You can evaluate stuff for type, and you can have declare things to just have arbitrary properties that effectively type them. We don't have that. So I don't know how to answer the bigger question. But something that has come up in this conversation that I think is relevant is that it's you face the problem of getting things either bloated, you may think of, or just too much to learn. So it becomes a sort of a there's not a simple answer to that, unless you do a beautiful job of your architecture such that you can learn it in a layered way, and gradually go meta. So maybe you're the one to do that.
And if you're interested in playing around with that, the Smalltalk runtime really doesn't care about classes. It cares about behaviors. So you can actually create things which can instantiate objects by subclassing behavior, just using behavior raw, and sort of create your own meta level structure. The whole class meta class thing is really kind of an artifact of the Smalltalk language and the code development tools that present it that way.
Mm-hmm. Yeah.
Yeah, I work with such things, and for instance, in Faro, there is this. For instance, there are traits, there are slots, there are now, let's say, first-class instance variables. You can have really ask a variable to be an object, not a dead string. So you could ask if it's referenced or other, and you can use this for cleaning the whole system and checking for unused instance variables or other things. So we work on that level as well. But to me, I mean, this is the most underrated part. That because if you have a class and you say, okay, here's a class that has a relationship to another class. So you not just have, let's say, okay, here's just an instance variable, and you have a, let's say, you all the time create accessors and that stuff. If you tell it, okay, this is a relationship to another class, and there's a cardinality, and it knows, okay, there's an account that has 0 to many account holders, then a lot of these things that are always done repeatedly, especially in let's say JavaScript, Java, and all that languages, you can totally automate consistency and other things, because you get them already from the meta model. So the more meta you have, the more you could do just by configuration instead of coding.
Hey Dan, can you hear me? This is David Simmons.
Yes. Okay.
So two things. First one is I really have never had the opportunity, but I'm going to take it now to sort of just thank you for gifting me with the Smalltalk mindset. That's really was a treasure. I first encountered Smalltalk in 1986 at the same time that I was looking at Gupta's book on agents, and I was working on Sun systems, and it was just mind-opening. And it forever changed how I thought about building code. And I started my first dynamic language. I was amused to hear what you guys were saying, because I got arrested by the FBI, and probably nobody knows that, in about 1980, because I'd hacked into NIMH. And why was I using NIMH's computers? Well, the reason was because I played a lot of D&D, and I was using APL as my first dynamic language, and I was building all these things, and the only place I could get to run it was on a machine at NIMH. I don't know if many people know, but in the 1970s, 1980s, most systems were really accessible. I had accounts at MIT and stuff, and I worked at NIST, which was then called National Bureau of Standards, on PerkinElmer's. But you know, the evolution in that time period, and just it was fascinating. The beginning of your talk, where you just sort of how you guys explored and what influenced you. You know, Simula, everything, just fascinating. And like I said, what you did in the 1980s was just, for me, was changed my whole thinking about how to build software.
Well, it was a really fun time. A lot of stuff just waiting to happen. But thanks.
But so my comment was, or my question was really, a lot of people have touched on sort of where's Smalltalk today? Why is it so bloated? And some people know that I spent a lot of time working on Smalltalk engines, but I think that software today is very complicated. I couldn't imagine being somebody learning software today, given my whole career of years. It's complicated. There's a lot to it. It's a very complex system to build an app when you really dive down through all the parts for say a mobile app that's talking to the cloud and other services. And at the heart of that for me is the challenges of, you know, distributed compute, which agents are right at the center of, and async programming. I don't, you know, as one of the questions I posed, there's a Discord channel where there's some big discussion. I don't know, and I'll end my question with, what thoughts do you have on sort of distributed compute, async programming for Smalltalk? A number of languages, and you're obviously familiar with JavaScript's approach to that. So I'll let you respond.
Yeah, there's a lot of directions like that we could go, and but I think it's the kind. I think you sort of have to back off and say, what's your user, and how do you want to deal with the problem of complexity versus learnability and stuff. and maybe but that might be something to come back to in another one of our meetings. I wanted to point out we're finally getting. I mean, we are getting pretty much over the normal time. That's not to say that people can't stay on, but if anybody wants to leave, they're certainly welcome to without apology. It's been great to have you all. It's really my first goal, and I think that was true for Craig and Vanessa as well, is just to get a little bit of camaraderie going here, and it's been fun.
Yeah, thank you so much, Dan.
Yeah,
Thank you, Dan.
Really fun to
Thanks a lot.
come here. Yes. And yeah, we'll see everyone in 4 weeks. Hopefully, is it 5 weeks, maybe?
Yeah.
Yep.
And people want to keep conversing, I'll be here for a while.
Oh, great. Yep.
Yeah.
I actually have to drop off, but it's been great. Thank you all for being there. You can't have a party without people.
Yay.
Hey.
All right. Bye, everyone.
Bye-bye.
Bye-bye.
Well, I'll stay till the bitter end.
I knew there'd be someone.
You knew it would be me. So
we've got 16 people left here.
So Craig, what's the story on the moon? The moon's above you.
Oh, a crazy person went out to New Mexico and shot some pictures at the same time every day for a month from the same spot, and this is what came out of it.
So is that actually on your room, or is this like a green screen kind of thing?
Oh, it's a total green screen. Yeah.
Oh yeah, now I can see on your headphones glitching out.
Yeah. The space between my head and the headphones is showing you a tiny bit of my actual room, but not much.
Okay. Well, Panda Man there is a practical effect.
That's right. It's all real. Wow. Let's see. I will stop the YouTube stream. So one moment while I deal with that.